Welcome to part 2 of lecture 2.1, Simplifying Expressions. So as we left off, we were thinking about simplifying expressions with one variable. But we're not limited to just one variable. As long as, or evaluating expressions with just one variable. So let's look at something that has two variables, and I can evaluate the expression for a value as long as I'm given enough information. For example, 2x minus 3y plus 4. If I'm given both x and y, I can evaluate this expression and find a value for it. If I'm only given x, I can't eliminate all of my variables. So for example, if x is negative 5 and y is 6, then 2x minus 3y plus 4 becomes 2 times negative 5 minus 3 times 6 plus 4, negative 10 minus 18 plus 4. Minus 10 and minus 18 is, negative 10 minus 18 is negative 28 plus 4, and then our end result is negative 24. So let's go with another problem. This time we have the expression of x squared minus 2xy plus x squared. As long as I'm given both x and y, I can find a value. So let's plug in, wherever we see an x, let's plug in the 3. So 3 squared minus 2 times 3y plus y squared. I'm going to do this in steps. Okay, let's do the plug in whatever we have for y. 3 squared minus 2 times 3 times negative 4 plus negative 4 squared. And I don't have any more variables, so I can find a value for this expression. 3 squared is 9. Negative 2 times 3 is negative 6 times negative 4 plus negative 4 squared is negative 4 times negative 4, which is 16. I know I did that a little out of order, but that's okay. It's all multiplication in the end. Now we have 9. Negative 6 times negative 4 is positive 24 plus 16. 9 plus 24 plus 16. 24, 16, 0, 1 is 49. Okay. Now you wouldn't think that sequences go along with evaluating equations, but it really does. If you recall, our counting numbers are 1, 2, 3, so on and so forth. What I can tell you is by giving you each subsequent number of 1, 2, 3, you can figure out what a sequence is given an equation. For example, if given 2n minus 1, what will we have? So let's substitute 1, 2, 3, 4 for n. When n is 1, then it's 2 times 1 minus 1 is 1. When n is 2, 2 times 2 is 4, minus 1 is 3. When n is 3, 2 times 3 is 6, minus 1 is 5. When n is 4, 2 times 4 is 8, minus 1 is 7. Our sequence is all positive odd numbers. Let's find the sequence of the following tables. So I have a couple of them here. Sequence of even numbers, which is 2n, and sequence of squares. So when n is 1, 2 times n will be 2 times 1 is 2. When n is 2, 2 times 2 is 4. When n is 3, 2 times 3 is 6. When n is 4, 2 times 4 is 8. And indeed, it gives us the sequence of even numbers. Now let's try the sequence of squares. When n is 1, 1 squared is 1. When n is 2, 2 squared is 4. When n is 3, 3 squared is 9. When n is 4, 4 squared is 16. Now let's think about how we might be able to apply this idea of sequences. So we have a cell phone company and it charges $35 per month plus 25 cents for every minute. So the expression of 35 plus 0.25t gives us the amount of money we'll pay using their phones for t minutes a month. So if we find the monthly bill for using one of their phones when we have 10 minutes a month, 20 minutes a month, and 30 minutes a month. So 35 plus 0.25 when t is 10, what would be our total bill? 35 plus 0.25 times 10 is 250. So our total bill will be $37.50. Okay, let's try 20 minutes. 35 plus 0.25 times 20. So it's 35 plus 0.25 times 20 is 5. It's 5.0. And that gives us $40. And for 30 minutes a month, it will be 35 plus 0.25 times 30, and that would equal 35 plus 7.5 for a total of $42.50. Now I could have written this problem like the table above. For example, n and 35, I'll use t since they use t. 35 plus 0.25t. When t is 10, our total was $37.50. Sorry, my writing was atrocious there. We'll say that's t, and we'll rewrite that as 35 plus 0.25t. Hopefully that's clearer. When t is 20, our bill was 40.00. And when our minutes, we used up 30 minutes, our total was $42.50. So whether you do long-handed equation or you write it in a table, it's in essence plugging in t, whatever value you have t, in your expression and solving. That's it for this video. So until next time, be seeing you.